I have started the recording. So, by the last class, we were seeing about launch templates, how we create target groups from the target groups, and then how we create load balancers, and then at the last, how we created auto scaling groups and mapped our launch templates, and we have created an like EC2 missions out of that, and then we were accessing the application from the load balancer DNS names. And then what we said, by using path-based routing system, I have created one more target groups, and I have created a one more instance out of that. So we were seeing the path-based routing, like how we application load balancer is like routing traffic to both the machines. So we have seen like how we can achieve the high availability and scalability in the cloud environment yesterday. Today we are mostly going to explore about this RDS and this document DB and Elasticsearch. So in general, there are like two types of databases available. So let me explain. So there are only two types of database. One is like SQL, one is no SQL. So SQL we know like structured query language. When no SQL is no structured query language. So the meaning of this structured query, what you do is like when you create a database server on SQL, what will happen? Here you create something called database. Inside this server, you can create a number of databases you want. Okay, this is considered this as like a number of databases we are going to create. So I'm considering like in the SQL, this is server instance where we have RAM, GPU, everything. So inside this, I'm creating a virtual environment. That is what I call database. Consider like this database one, database two, or database three, something. Inside this, there will be some section called schema. So mostly all the structured query database are like schema based. We call it a schema based. Why we call it schema based? Like inside this schema, you have inside the schemas you consider I'm going to have a schema one, and then you can have schema two here, and then you can have schema three. So inside the schema, now you will be having your tables, functions, procedures, and everything. So this how the structure of SQL database is going to look. Okay, so you are going in from the cloud environment, you will be going to create a server. Inside the server, you will be creating databases. Consider it as like a dev database, or like QA database, or like an UAT database. If you needed, you can, if your organizations agree, you can create all the databases of the non-prod in the same server. If not, you will be creating a different server for different databases. This completely depend upon your projects. So inside your databases, you will be having n number of schemas. So this schema is completely for is for like authentication. This schema is for application to store some events. This schema is to like to store some raw data. Then another schema will be where we have like the processed data. So because you get usually whenever you have a business applications, you get in raw data from somewhere, and you have to store that raw data, and then you have to store that processed data. So all the data has to be stored in SQL, because after some particular time of an audit or some any issue happens, if even like any issue happened for your processed data, consider some issue happened for your processed data, and whatever the process that happened by your application is totally wrong. So then you have to know, right? Like the for like you will find the time period from this time period to this time period. I have some issues on my application. Whatever the data is stored, it's wrong. So I'm going to redeploy my code, and then I know the raw data has been there. So I'm going to consume it, and then I again clear the data. So these are the kind of manual works. Okay. So inside the schemas, you will have the tables. So in the tables, how you will have is like, so this how you will have. So inside the tables, you will have n number of rows and columns. Consider This as a always considered as a rows and column. Each column will have an name. Okay, okay. Consider this table. The first name is like name, and then it is like query ID. Let me zoom it out. Hmm. And then it is like some query ID, and then this is some random strings, and then this is about some time format. These are our headers. Okay, these are our headers for each columns, and then you will be having the entries here. The first entry here will be there, the second entry will be here, the third entry will be here, and the fourth entry will be here. Like that, you will have like n number of entries. Like you, okay, this how the tables will look inside the schema. And then the function, when I talk about this function and procedure, what are these function? You might have heard of about tables where we store the data. So it has like a number of columns, a number of columns and rows. So we each and every column we title them with an with a primary key. For now you just understand this. And then in the functions and procedures, you will be writing some um, like some loopings and some functions. So like so you have get this data from schema 2 for table number 1, and then get some value from schema 3 and add them and put it back in the schema 4. In the schema 4 create, there will be some table for result. Put this there. So you will have functions and procedures written like this. So what it'll do, it will take some data within your database, be instead of uh, like analytic from the application end, you will be writing it as in functions and procedures. So okay, that's how these functions and procedures will help you. But when it comes to that, is about the general thing about SQL. When it comes to no SQL, you don't have this kind of anything. You just create some server. You create in general, you will create some NoSQL server, and inside that you create some database, like whatever database you want. Consider like a database 1, database 2 or something. Here there is no concept of schemas. Here there is no concept of schemas. In this case, in the previously in the skill, what we did is there will be some tables and functions and procedures will be there, but in NoSQL, no schemas will be there. So whatever the data you want to store, it will be mostly stored in like some JSON files or raw data. So consider it as like an like a file. Consider it's a JSON file. It opens within curly brackets and into the curly bracket, and then it has something called ID, and then message. So anything, any key value pairs. So on any key value pairs inside the JSON it can have, and then you consider some values. It will be like some dictionaries, anything that can it hold on dictionary. This is like a raw data. Here you see it is like a it's like a table. Each and every time you have query, you have to call this primary key, and then you have to do some select queries and find command like where commands, and there are different join commands are there. So those things are all will come for SQL, but this NoSQL is nothing. Is mostly this NoSQLs are used to store some raw data things. Okay, that's a basic difference about SQL and NoSQL. So in cloud, in AWS, for SQL, we have something called RDS, Relational Database. The other name for SQLs are like relational database only. So they have like Amazon RDS. For NoSQL, we have something called Document DB. Obviously, you can also have document MongoDB as well. So there are like a number of uh, what do you can say, database flavors are available. So here the most used to know NoSQL was document DB from cloud. There we call it as RDS. So in the RDS, if you come, there are different types of databases are there. See, everything is SQL only, but there is something called SQL is there, MySQL is there, and then like Microsoft SQL is there, Oracle is there, Postgres is there. See, like if in RDS literal you can create whatever the database type that you wanted, you can choose. So these options are everything is available in the RDS. But additional to this database, these are like some third-party tools. Okay, so these are like each and every MySQL, Microsoft, Oracle, Postgres. They if you want like this MySQL Postgres, you no need of license. If you want some Oracle SQL database, you need to have separate license with the Oracle team as well. So, but in order for compared to all these databases, there is one more database available in RDS called which is we call Aurora. So this RRO instance, so this is the database that offered by AWS system. AWS developed this kind of SQL. So what they AWS tells like compared to this SQL database types that you get from outside, from this Aurora is much more faster. That's what they would claim. So there we will see in detail about what are the functionalities, characteristics that get different from this MySQL and Postgres with this Aurora. So that's it about the basic databases, and we have something called elastic cache. So consider you have EC2 machine, you deployed your application. Consider you have your UI. UI means always consider it as a front end. UI you and back end application. UI is just an from the browser you want to view that. So for UI always calls to backend. This backend always talks to databases. Okay, both these applications are installed in EC2 machine, and this EC2 machine is talking to database. Consider it as like any RDS for now. Now, what will happen here is like we each and every time, if there is any some select queries are there like any repeated queries. So from the UI each and like because there may be like 1,000 users are there. Each and every time they come to UI, they do some query and then it has to go to database. What will happen? The load on the database will increase because each and every process from the UI in the EC2 machine, it will be running as a process. When we were seeing that PS and EF or PS aux, we were seeing some process IDs, right? So with this is what happens when an application runs, it will create an process ID. So from the database point of view, you can see it. It will create an process ID, and then you can see there is some select query is running on, some insert query is been running on. So and then these are the basic functionalities of database for SQL. So the most common thing we know is like select query. So whatever it is there, just display for me. And then there is some insert query is there, and then some like delete query is there, and then something called update query is there, and then something we call truncate. These are the general queries that we query types that we tell. Select means you just select, insert means it will insert the data, delete means delete the particular data from that particular column. Update means instead of data like key value per update the value. Like if in value is present is like AWS value, replace it with some other value. So that is what we call update. Truncates means you whatever in the tables, just it will you just have this headers only. The primary keys will be that inside you add some data, right? If when you choose for truncate, all the data will be deleted. So and then what we are presently basically do as a DevOps engineer from the database point of view is like we mostly what we do is like we kind of do the backup and restores. We do the complete backup of DB and restore, or you take in particular table and then it's very easy once you connected to with your PG admin tool. So in order for us to even though when you like create this AWS RDS from the AWS, it is not giving you a good visualizations. So sometimes you have when you are using some RDS tools, databases, you can use some tool called PG admin. Consider I'm installed like Postgres server. Postgres is also one type of an MySQL. When you install that, you use pgadmin tool. We will see this in our class today. So we will see the visualization of this all these tables from there. So we'll take and backup and we do the restorations. So this how the basic work for DevOps engineers around the databases will be like. So we will be responsible to create the databases in most of the cases, and then like we'll but whatever the tables, procedures, schemas, whatever these things inside the database, that some other database team will be there. They will be take care. Okay, you just create the infrastructure, you just maintain the infrastructure, and you have to control the network between like this EC2 machine to database alone. Rest they whatever the schema that you write there, that they will do. So one more important thing I want to talk about is like when it comes to SQL database, um, there are two main factors I want to talk. Whenever you have some SQL database, throughout as a DevOps engineer, I am talking about in general now. You will face two main issues. One is what will happen your EC2, your application is running on EC2 or something, when it's trying to fetch some queries from the database, it will take more time to load. So people will ask why it's taking more time, what you will do. Then you should tell something called I have to do indexing, index tuning. We call something called you can search about. I'm just giving in some general view on. We are calling it as index tuning. So uh, and then we would be doing some archiving. So these are the main two things that we do whenever people would say like in like it's a common practice in any organization, because each and every day your databases is getting loaded with new data, right? So some of the old data is not needed for you. Those times there must be some scripts are there, like some pipeline jobs will be there that will be taken care by some data engineers itself. But I'm giving general view that they have to archive this data. And this in index tuning also they will take care. So what this index tuning will do, they will bring up the new fresh data. Yeah, Lokesh, you wanna ask something? Um,
Sorry, I'm facing bad internet, so that only I
uh,
thought it's from your side.
okay. No issues, no issues. So you can understand, right? Whatever the terms I speak, I'm speaking, giving some lot of details today. In general, these are the general things. It's not like related to cloud or
Yes,
something.
yes, yes.
Uh, and then we will do some index tuning as well. So this is what we basically do. And one more issue, because if you don't do this archiving and index tuning, you would be facing some issue called deadlock. You have to just get familiarized with the terms whatever I telling today, because these are the general terms. You as a DevOps engineer, you hear from your developers or your database teams. Okay, our part is to create infrastructure, but they will take care of. But you should be aware of about those things, like how they are doing this index tuning, how they are doing the archiving of the database. Archiving means syncing, consider like syncing up the old data. So compressing. So, and then there will be something, if you don't do this kind of things regularly, you will be getting the deadlock issue, because application will take so long. So, what will happen is like, I consider whenever you triggered and request for your application triggered and request, it comes to database. If you don't do this proper index tuning and archiving, so large number of data sets will be there. So it will take large time to do the process. So like each and every process will take almost 1 hour. So what will happen? This 1 hour, if the process is running on the database, it will going to increase the CPU and memory utilization. Mostly, it will affect your CPU only. So in order to avoid this kind of activities only, you have the database. Uh, okay, so or else, yeah, there is one more thing we can do. When instead of having this EC2 instance always talks to database, only the first time whatever the query that you wanted to access from the backend, it will fetch from the database. Rest next time, whatever the query that you got successfully from the database, they will put it into some elastic cache. Some we in AWS we call it as elastic cache. The real third party tool, they call it as Redis. Redis are like some in-memory cache databases. Okay, these are actually not an original database. So you whenever you consider your application requested some query from database. So the first time it got it. So if you do the second time also, it also again goes to database. But you don't want to do that because you know the end result. The first time itself, you know the end result for this kind of query for this selected time frame. The main thing is that the selected time frame. So this would be the answer. So why have to you go and disturb your database again? Those times and all, you put whatever the query you stored here, like put into some Redis. So in AWS, we have two kind of elastic cache. Similar to Redis, we have some Redis and Memcache. So this how the general things of databases will be. Apart from these things, whatever I told now, so um, like whenever I deploy some databases, let me clear out this thing. So we all know database is the most critical part for any business use cases because it actually stores the data. So consider this is my three subnets. Okay, this is my VPC or consider less VPC in like any region, and it has three subnets. Consider like not a subnet like an availability zone. Consider this as a region. This is an outer layer is a region. This is availability zone 1, availability zone 2, availability zone 3. Whenever you create some production cluster, you always should keep in mind that your data should be at least replicated in two availability zones. That's how you should create. Because whenever I create some RDS now, so whatever I will do is like I create in a cluster format. So the main primary server will be here. The primary server will be here, and then consider some read replica will be here. What is this read replica? So all the consider it as an application. It's write data to the primary database. When I create an RDS, I have created two servers now. This is the primary server where all the write and read operations are done. But this is my read replica. It syncs the data asynchronously from the primary server, and then this server is particularly used for developers to read the data alone, because developers each and every time they cannot do the query to the primary database itself, because obviously it will increase the load, it will affect my CPU, so it will affect my application performance as well. So like if a number of factors are there, so those times what they should do is like they should do this read queries from the read replica alone. Then I also talked about memcache also. So like memcache like or like elastic cache or redis or something. Then you are using read replica. Then you can ask me why are you using the redis. Both the use cases are completely different. This Redis is used only to save the already queried what do you mean like a queried function. Okay, so whatever your application when it queried for the first time, those things will be stored here. But when you are this read replica is actually for deployed for the high availability purpose, because in the last class itself I told when you will achieve the high availability when you have like two instance in two different availability zones. Now my because if I am deploying the RDS in the single availability zone, consider it as like 99.9 percentage of availability. When it comes to two availability, like each and every server it's like 99.9. It's like consider like 99.90. Okay, actually it's like 90. When it to combine, it is give you like high availability of 99.95 or 9. Okay, this how the high availability will changes. This is are like small numbers, but when you calculate for an year, this numbers will be get differed. So so in production environment, you always remember you should run like one primary server will be there and then one more read replica should be there. And then you will be having some Redis. These are not a compulsory option. This read replicas are Redis. These are completely based upon your application use case. I'm just giving one view because you just need to gather these informations because because this will be helpful when you design some architecture or something. Um, and then this is my primary region. Consider it as my primary region. Each and every company will have their primary region as they will have their secondary region as well. Consider this as my secondary region. Okay, what I will do, this primary region is fine, this read replica is fine, everything is fine. Um, Lokesh, are you able to hear me? One second. Yeah, I hope you can hear me.
Yes,
Ah,
it is.
okay, okay.
Yeah, yeah, I can do.
So consider like in any organization, they would be whenever you go for production, they will be calling it as a prod environment as well as they calling going to call it as DR environment. DR mean disaster recovery. Keep in mind. So because if the primary region goes down, so what will happen, my primary server will go down and the re-replica will go down, and then this redis also will be in the primary server, it will also go down, right? So what else then how I can serve my application to the end users will be, right? So there will be like around 1 lakh users will be sitting here. How I can compensate them, and I will lose all the data. In those cases, you should have an read replica in secondary region itself. Okay, consider now this is my primary server, you have one more read replica, or we call it as standby instance. So this also gets syncs the data synchronously. Okay, we call it synchronous and asynchronous. Synchronous means it get data synced immediately. Asynchronous means there will be some lag time for read replicas. So even you can promote these read replicas to standalone. Okay, standalone means these are actually forming in cluster. Right? This is primary. This is sending data to read replica, and it is sending data to read replica in secondary region as well. So when you want, when you feel, so this is fine, I want to take this as a separate database server, even that's possible. You just select the server and you make it as a standalone server. Standalone, it is comes out of this cluster and you can access this application, and it will not get an data again unless you manually add it, because primary server alone gets an application adds there, right? Unless your application adds data, there is no data, new data will comes to it. That is what we call standalone servers. So whenever this primary region goes on, you create one more read replica or one more standby server in the secondary region. So if the total region goes down, there is an options in the AWS. Either you manually or automatically, this server will come up. So here you can access all the application data. So that's it. The basic things about uh, RDS, Elastic Cache, uh, unmem cache. Uh, okay, let me go back to the portal. So this how the UI looks, right? So you go here and then you click RDS. Once you click RDS, this is how the options you can see. So here what you can do is like you click the databases and then you click create databases. So here it is giving me like standard create as easy create. Easy create will have less options, so you can create it immediately. You don't need to select much more options. It will choose most of the default options. Let me go with the standard create. So you can have much more options. So after I choosing the standard create in the engine options, you can see Aurora MySQL compatible, Aurora Postgres compatible, MySQL, Postgres, MariaDB, Oracle, Microsoft SQL, IBM DB2. So all these are like SQL types only. Okay, everything will have the same kind of schemas, database, Swift tables, functions. Everything will be same, but their functionality will be little differ. Okay, these are like from each and every companies, like each and every separate MySQL or Postgres team is there, they will be working on this. So this Aurora is they took the MySQL and they developed their own MySQL. That is what we call MySQL Aurora. And then they took the Postgres and they developed their own database. That is they call Aurora Postgres. So what they claim is like compared to this normal Postgres, this will be like 3x faster. The Microsoft Aurora is like 5x faster than the MySQL. So that they would claim. So and they would offering a lot of features in it. So we will be discussing it in the next slide. First, we will see how we will create the database here. What I do is like I choose Postgres SQL, and then after I choose my Postgres SQL, it will be asking you to choose the which version of Postgres you want. I just choose any random versions from Postgres 14. You can choose any versions, and then if you come down, the main thing would be like in the template section, it is asking for which environment you are creating this database, or it is like production, or it is the dev test, or it is in free tier. I am actually creating that free test, but whenever you go for interview something, you should tell for dev and test I created with this dev test. For production I have created with this production template, because what's the difference is like if I choose the production template alone, I would be getting this availability and durability. Okay, if you see when I choose the production, I can choose this single availability zone. That means a single primary instance is only going to create in the AZ availability one. So but when I three options are right. In the second option, you can see a primary instance is going to be created, and it is going to create a standby or replica in the availability zone 2. But when you go for multi-AZ DB cluster deployment with three instance, it is going to create two reader endpoints. So that's the difference, because it is giving you more availability. If you consider like two availability zones are gone, you will still have the AZ3 will be running, where you have all the data has got replicated. So that's the meaning of this. When you go for like free tier or something, you will not get these options. Okay, when you go for dev test also, you will get this option, but not comparatively effective to the production environment. So I'm just for this demo purpose, I'm just using the free tier, and I'm just choosing the single AC DB deployment. And then I just wanted to give some database name. Consider it as like I'm giving like Phoenix database, and then in the master username will be like Postgres. That's fine for me. And then here you see credentials manager, because this is a username. Username by default, it should have some passwords, right? So it is asking self-managed or managed in AWS secret manager. AWS secret manager is not a big service, so where you will be storing your key value pair. Whenever I am talking about key value pair means, like consider like name is equal to Satish. This is an key value pair. Okay, because name is an key here, value will be Satish. This so for this database password to be stored, either you can manage in AWS. When I choose these options, so it will create its own password, and it puts the password there. So the each and every time you have to fetch the password from the AWS secret manager. This is how most of the organizations uses, because this is the most secure way. So you will not be exposing your password, right? Now I'm just using the self-managed workspace, and then I'm giving some password here. Uh, mm. And then in the instance configurations, so I will be selecting on my free tier. So I'm selecting in like a smaller type. I think this also, both the things are same here. uh, Let me select a smaller one, because this will be going to be costable for me. I just select the instance type. Instance type, like what kind of CPU you need, what type of CPU and RAM you needed, just to select that. So if you go for higher production environments, you will have higher machines also available for you. So I'm going with a free tier. That's why I just see this two machine type available for me. And then in the storage, I just whatever the storage type you need GP2, GP3, IO1, IO2, whatever you need, you just choose it based on the IOPS that you require. Okay, I'm just going with the GP2 here, and the allocated storage is 20. If you open this additional storage configuration, you see some option called enable storage auto scaling. What will happen, because I'm creating the storage for only the 20 GB. If the 20 GB is completely filled, that's it. There is no space to append the data to my database. So those cases you should enable this parameter. So it is asking you threshold. So like when I should like what's the maximum threshold. So here my initial storage is like 20 GB. Until 1000 GB you can scale up automatically without my knowledge. Okay, so without your manual work, it can expand. So that's the meaning of these things. So I'm just disabling it because I don't need here. And then it is asking for connectivity. This is one of the important options. Mostly whenever we deploy applications in the cloud perspective, we will be deploying either in EC2 or in Lambda or ECS. ECS means container services, or Kubernetes. We know Kubernetes, like we you Dockerize application and then we deploy them. So that's how we deploy. If you think like your application is getting deployed in EC2 and you want the connectivity, you can just select this option, because in the backend it is going to create you the security groups. So yesterday we have seen, right? We have what we yesterday did is like, by simple thing, I created a security group for load balancer. I created a security group for EC2 machine. So in the security group of EC2, in the HTTP port, I allowed the port HTTP port 80 from the security group of load balancer. So only this HTTP 80 port will be accessed from the load balancer. That's how I configured. So this is giving a direct option. Previously we used to do this thing manually. Now AWS is upgraded, because this is how we do follow standardized. So if you want, don't connect to EC2 instance or connect to EC2, it will update these characteristics by default itself, because you have and then it is asking in which VPC you have to install. So I'm just choosing my general VPC itself, my default VPC in the region, and then I'm just selecting the subnet groups. So we know I have three subnet groups here. I'm just making choosing all the in the default VPC, choosing all the three subnets. And then if you come down, public access. So RDS by default it is publicly not accessible. So it is accessible only within the VPC. Okay. Um, if you consider it as an VPC, only the if database sits here, it is accessible only within the VPC itself, unless you make it as public. Yes, if a public access is there, it by default it is enabled is no. I am just keeping this no here, and then it is choosing the security group, because what is the firewall you want to apply. So because we know by default all the inbound traffics are blocked. So but my in my default VPC the traffic is open, so I am just selecting for the default VPC itself. So we have an option here called RDS proxy. What this RDS proxy does? So so this RDS proxy, it is used. It's kind of an like an what it's like. It's kind of an Redis only. So what will, let me consider, this is my database. Okay, RDS proxy is going to sit here. RDS proxy, and then database RDS. So each and every time, like application one is there, application two is there. So if instead of accessing the data directly from the RDS, so this query will go from RDS proxy. This is acts like an Redis only. It's like giving they're giving an inbuilt options. So cloud is like like each and every year it's like keep on expanding. They will be adding a lot of options. So it will comes to RDS proxy. If any select queries or some data present in the RDS query, it will like forward the data to the application, instead of making a load increasing in the RDS. That's the use of this RDS proxy. So I don't want to comment more about these options. And then if you go for additional configuration, it is giving by default. So for any database, like there is a default port is there. If it is considered like Postgres, it's always the default for port for Postgres like 5432. If you go for MongoDB, listen NoSQL, it's like 27017, and then it's some SQL. I forgot the port numbers. So each and every database runs with an default ports. So if you want to change that, you just choose the port number here. But I'm just choosing my default 5432. And then if you go for database authentication, here comes the main part. So here, if you see in the top, what's the username I have created for the master username should be Postgres, and I have given some password. So either you have to access only with that or with IAM rule. So that's the question. Whenever you create, uh, so I created a username password here. By using that I can access. When I choose the password and IAM authentication, in IAM I was creating different users, right? I created user for you, I created user for me. by using that also they can access. Either they can use this username password which I created, because but these are like some master usernames. Okay, we should not share with table unless only with some DB teams or only with the DevOps people must be using this username passwords. For developers and all, what we will do, we will create an IAM users for them in the we will create an username there, and then we will provide some rules. This guy should only have read access from the database. This guy should not do some, should not have admin credentials inside the Postgres. So we can do that. So by using their username and passwords or by tokens, they would by using the AWS CLI command, they would be generating some tokens. By using their username and token, they would be authenticating. So that's the use of this thing. So I'm selecting just here like database authentication as password authentication. And then monitoring is there. Monitoring is just like so whatever day-to-day activities, like who are accessing, like who like what query has been running for so long. So all these database insights will be collected. So all these details, like each and every time some queries will running, this data has been added, some application threw an error, so somebody tried to connect. So these are the some of the general monitoring logs. So all this will be stored in somewhere like in S3 or some wherever you want to store. So I'm making a default option is like retain 7 days of performance history. And if you want advanced, if you go, you can go for advanced option itself. It will show for 15 months. So I just don't want it. I just choose database insight standards. And then the retention period. Retention period is how long you have to maintain that log history. I'm just choosing it as in 7 days only, and just I'm disabling these things. Uh, I'm just disabling this performance essentially just to give you more insights about logs and how you can like enhance the performance. So, and then if you come to additional monitoring, uh, it gives it just any additional features. It gives like more options here. I don't want to talk about these things. If you go to additional configurations, what kind of database you want to create, it is there is something called database option. So the, right now what I have seen, we have seen like an username and password I have created and a port number. So these are like there are five common parameters that is will be helpful for you to connect to your database. Those things are like host name and the DB name and the DB port and the username and password. So we will see that one of the thing is like database name. I'm just going to create a Postgres. So I'm going to create a database because this is a server. Inside the server, you will create a database. What is asking me? What is my initial database? I'm just typing it up as a database, and then default Postgres 14, and enable automated backups, it's needed or not. So I just click and enable automated backup is to true. So because what will happen when you do this enable automated backups, for like how many days you want these backups to be kept. If from in AWS it is available from 1 to 35 days, so you can choose that. So because what will happen, and it says like a point in time snapshots, what will happen, so this is my RDS server, right? So this is time is like now 9 o'clock. 9 o'clock, it will take a snapshot that is available for you. Okay. Snapshot means it will just take whatever the data at present at the 9 o'clock and put it here. And then 9:05, some it will take a database and then store. And then it's like 9:10, it takes some databases. That is what we called an like creates a point in time recovery type. Point in time means for each and every minute it is taking a backup. So because if something happened to a database or some data, there is a lot of chances when applications are running, corruptions can happen. So those times and all you have to like restore. Okay, the most common words you can hear is like the backup and restore, because these are actually backup. The restore means whatever the data or like how the state of the databases were at 9 o'clock, it will be get restored to like it will be available for you in the RDS. You can do the point in recovery. So it is like giving me option for automated backups for 1 to 35 days. You see how much time frames will be, how many backups it can choose. That's available in the cloud. That's why we are moving our databases to cloud, because it's giving like good point in recoveries and good man upgrade. mainly like upgrade, because each and every time this Postgres or MySQL will come up with some patch version updates, right? So those things and all, they will take care for us. So you just have to tell them which time you have to do. So right now I don't need any automated backups here. Uh, and there is option called backup window. When if there is any particular time that if you like to do the backup, that you can select here. You can see it is giving me option, right? It's 12 o'clock, duration is 2 like 5 at this time. So I don't need of any backups here. Just I'm disabling it. When you go for backups, it will ask you what is your retention period, when you want this backup to be taken, everything. And then we all about know about encryption. So whatever the data we store in our databases, it needs some encryption. Encrypted means it is encrypted by some AWS key itself. Only if you have that private key alone, you will be unlocked and you able to see. So if you're not, you will be seeing some random strings in the columns only. Most probably all the customer data that we put in the database will be encrypted. Only the privileged people means the higher people in the organization will be able to read the data. So these are like an security steps that you can take up. So I'm just disabling the encryption here as well. So if you go for encryption, you just select, it is giving selecting the default KMS key that is available for me. I'm just disabling that as well. And then maintenance. In the maintenance, it is asking like enable auto minor versions. We know, right, like what is the minor version, major version. So if we, it always the versioning will be looks like this: 1.0.0 or something. The last we call patch version, the center we call as minor version, the first one we call as major version. um, if I want to upgrade this minor version automatically, it is asking me. I'm just selecting that option. So at what time how to do? Because your application will be serving to the end users by 24/7. So but you will get some downtimes, okay, right? Especially like Sundays or Saturdays, mostly your applications will be in downtime. No, there will be less users will be there. These are like some general things in organizations. So those time you put some choose a preferable time and then put it at some Sunday, and then you choose the time. So this patching will occurs only on the preferred time alone. So because when patching can be whenever, like AWS can release an person, this patching they can release this version whenever they want, but it need not to be happen, right? In those cases, you just put a time for that and then you choose it. So for now I don't want to anything, and then uh, now you see, if I come down, you see how costly the service is. Amazon RDS free service available for 12 months, but 750 hours of T2 micro or T3 micro, like 20 GB of general purpose. Only this is free. If I go with other configuration, it will be very costly for me. That's why I didn't choose this encryptions, automatic backups, and everything. Because I already for this demo, last day we did this. Load balancer and target groups, and I forgot to delete those things, and it costed me really high. So always remember, whenever you create the service, you practiced and then you delete it. You keep on remembering these things. Uh, mm, Now I know whatever options I choose, and let me just get reviewed and then create it now. I choose a free tier, Phoenix database, Postgres, password. Uh, So not only these options, like a number of options that is available for the databases, but for now this we let's start with the basic only. So now a Phoenix database started to create, and I know it will take a long time. Um, and it is suggesting me to use RDS proxy or Elastic Cache. So I told, right. So whenever you create some databases, in like the already queried, whatever the application's queried patterns will be there. So to store them, you can either go for Elastic Cache or you can go with RDS proxy. The best practice is to have something like this Elastic Cache. This is very because this is from like Redis is like a third party tool that's being used for over years, and AWS is aware about that. So they brought this Redis connection with them, and they developed something called Elastic Cache. When you go creating this Elastic Cache, you will be seeing two options, like one for like Elastic Cache of from Redis and Memcache. In that itself, there are two types is there. We will discuss that about that also in our class. Uh, and then it's asking me like use RDS proxy or something. I don't want to do that, so it will take some time to create. Let me go back to the slides. So I plan to see about RDS and Elasticache and DynamoDB. RDS and Aurora are same. It's Aurora is actually available inside the RDS only. Instead of choosing the Postgres, I will be choosing Aurora here. So I plan to take the Elasticcache and DynamoDB as well, because not in this big scale you will not see this much options there. You will see like similar kind of options in the document DB as well as in the Elastic Cache. So, but you just understand the use cases. We will see about that also in like 10 to 15 minutes. Let it create. Also, this whatever I discussed in this class, it's actually available in the slides. Um, So why we want this RDS is like automated provisioning, because OS patching also they can do, continuous backups is available, monitoring dashboard is there, read replica is there, multiple across DRs you can do, like maintenance they would take care, storage auto scaling is there, scaling also you can do, because here I went for like D3 micro. If you want to do, you can do the vertical scaling, and then auto scaling options we have explored, read why we need replica that we discussed. Um, and then networking, this I want to talk. So whenever you put a read replica within your the same region, that for the data to get synced from the primary server to the M means master, R means read replica, there is no cost for that. But whenever you do for cross region, because in DR activities you will be having some read replica in other region as well, right? Consider this as US used to one, and if like EU west to one B. So you are saying saving it is in different region now, right? Those times and all it will be cost for you. So it's like obvious. Whenever you in even sometimes whenever you copy data from one availability zone to another itself, sometimes it costs, sometimes it will be free. So this and all you should keep in mind whenever you create an architecture. Okay. So and then we discussed why we need this multi-AZ thing. Multi-AZ means multiple availability zones, and then you should have some instant standby. So these slides will give more key points to you to read for to get prepared for interviews, everything. So I just talked about and then single AZ to multi-AZ, why you need this, so how it will occurs. So whenever I create a new standby instance, what will happen? From the master, it will create a snapshot and then restore. That's like an backup and restore. So we discussed these things. RDS custom option is there. As I told, right, licensing is one of the important factor, because this MySQL, Postgres, and all, like they already have a partnership with AWS. Have a partnership, so they brought this Postgres with you. Okay, they will take care of the licensing backend. But for this Oracle and Microsoft, if you want to deploy these things, you have to talk with that separately, so with the Oracle support and Microsoft teams to bring up this SQL servers in the cloud platform. You just need the licensing. But apart from that, you compare to this and PaaS service, right? You no need to take care of this underlying infrastructure and all. You just create it and you just use it. But in RDS custom, you will be having access to the underlying OS itself. So whatever the database configuration that you will, if you want to change something, that you can change. So that's possible only for Oracle and Microsoft. And then we were seeing this Amazon Aurora as well. So they'll say like it's globally available, and then it's like they will like it provides like high availability and read scaling. It is like the same thing. This one I want to add here. Whenever your client, this client means your local laptop, so there will be two endpoints will be created. This writer endpoint will be given to application only. You should not share you can share with the people, but they should not use it. This is just an host name. So this host name will be different, this host name will be different, because applications will can use this writer endpoint, so they can update or read and write the data. But this reader endpoints, only the local developers will use it to just to read the data from the read replicas. uh, so you can see like it's like same only, like whatever the time we talked with Aurora. um, and then this RDS backups, restoring points and proxy. These are only everything is same. So let me go back to the portal and then see it's now it's got created. So there is something called PG admin tool. Is a PG admin tool is Postgres tool. It is actually installed in my laptop, and I have some servers with me. Those are like my uh, servers which I tried before. Like these are some other which I do some other works as well. So if you see a Phoenix database a server has been created for me here. If you click that server, you will be seeing multiple options here. In the connectivity, you see the main thing is endpoint. You just copy that endpoint, you come to the PG admin tool. So for whenever you create any servers from the cloud, either you will be using for Postgres, you will be using this PG admin tool. For SQL, there is something called SQL. Microsoft SQL tool is there. By using that, you will can access because it will give you better readability from the UI. Okay, what I go. I want to install the PG admin tool from the internet. You will see server section here. You click the register and then you click the server and then you choose the in the server here you can give any name. I just give it as AWS RDS Postgres. I just give the random name here. In the next section, you give the host name. Whatever the endpoint you copied from here from the cloud, you just give that. And then I know by default it's Postgres and it's running in the 5432. And my maintenance database is like Postgres only, which I have given, and the username also Postgres only. uh, Database is different, username is different, both are I created the same name only. So here I am giving the password which I created, admin. I forgot the password. Wait. When you do it, it will connect to the database to the cloud environment. Let's wait for it. uh, oh, okay. It is blocking from my security group only. I know. Let me. And I'm not able to update it. Uh, STR. I should have been added this and security group. Yeah. So, but this how you create. I'm just giving you a demo. You just when you click the password and you saved it, the PG admin tool will be open for you. You will just mostly as a DevOps engineer, you would be just reading or do some small insert works, or you do like copy and restore only. So I want to show those options for you. So that's fine. So any other doubts? Like, so I think it's already more than 1 hour today. For only RDS we can cover. Rest we will see tomorrow, or I will show you. I will delete this database and I will recreate, and then tomorrow I will show you how it will be looks for you in that from the UI, from the RDS. Okay. Any other things, Lokesh? I'm stopping the recording.